Incidentally, I've been coming to the CHPC meetings, I think, for more than 10 years now. So I'm also one of the old hands here, just like Birelli. I'm going to be more or less talking about computational science, but you'll understand that nowadays we use several terms interchangeably. So we sometimes talk about HPC, data science, computational science. And now there's also a talk coming back to a very old topic, which was scientific computing. So I believe some of what we have listened to previously also have their roots in scientific computing. Are we ready to start? I was just trying to fill in. Okay, first slide here. Oh, so I can do it myself. Oh, that way. Okay. Okay, so. Okay, finally. Yeah. Okay, so I'm coming from the International Center for Theoretical Physics, which is located in a part of Italy. As you can see, it's on the coast. Sorry, it's on the coastal area, and we have a nice castle as part of our landscape. Unfortunately, my office is not here. My office tends to be in one of the buildings here. So yeah, I think this one here. Okay. So just to start us off with a quick overview, I'll introduce ICTP because I believe a lot of people here are just hearing about the ICTP for the first time. And then I'll talk about computational science, more or less try to define what I'll be talking about when I say computational science. And of course, HPC's training. And then I'll review briefly some of the international approaches that have been used over the years for training graduate students, particularly in the last decades. I'll show some success stories as well. And I'll talk about a new future initiative which the ICTP is involved in, which is a consortium on scientific computing. Okay, so this is roughly just about me. It's a boring kind of CV, but I think it's not too interesting. So in the interest of time, I will just skip it over. So we have the ICTP is short for International Center for Theoretical Physics. It was founded by a Nobel laureate in the year 1964. And the idea was to enhance international cooperation through science. It combines world-class research and tries to build scientific capacity, especially in the developing world. Currently, we are governed by a tripartite agreement, which involves the Italian government, UNESCO, and the IAEA. Okay. Core areas we follow at ICTP are research, education, and outreach. We do have some in-house research groups in some areas of physics. And we're also very heavily involved in mathematics. Pure maths is that group focuses on pure maths, but in the last decade, there has been some new areas starting up, such as quantitative life science, the high performance computing and sustainability, sustainable energy as well. Our Earth system group is also quite well established. And I believe the head of this section is actually one of the Nobel laureates a couple of years for the work, I think a few years ago, with the work on the ICPC panel or something like that, or ICPC. Okay, the activities that happen at ICTP tend to follow a researcher or an academic all throughout their career. So we're able to follow people from when they are students, we have programs that suit them, to when they become junior researchers or graduate students, to even when they are now established as academic staff or some other programs in their own rights. So all the way to when they become very senior professors and things like that. So it's a really a commitment, a work with individual researchers. Interestingly enough, we've had researchers that have gone on to become maybe ministers and things like that, who have passed through the ICT program. We try to focus on encouraging what we call brain gain, and we build skills and training for scientists from developing countries, mainly through 60 or more workshops and conferences each year. And we have about 5,000 visitors. This is one of the programs. We have a postgraduate diploma program in physics where we have students coming from all over the world. As you can see, there's a wide variety of people from different continents all meeting together. And more than 75% of them actually go back to their countries of origin. So when they finish. The visitors tend to be balanced, have sort of a balanced representation between developing world and developed countries. So there's a nice mix happening at the ICTP almost during the year. This is some testimonials from David Gross. And then our impact areas cover lots of places worldwide, and also a testimonial from Stephen Hopkins. So that's just been a whirlwind introduction to the ICTP. I'm sure we'll get more from the ICTP website if we need more, or we can always have some questions or comments. So now to computational science. I believe a lot of us may have seen several representations. These are just two of the common representations that are around that speaks about the fact that computational science is overlays or overlaps three separate fields: computer science, mathematics, and at least one other discipline. Some of the key things that we can identify with a computational science program is the fact that you probably have to do some modeling. You need to probably look at algorithms. And most of the time, it's always necessary to relate whatever solution you get back from the computational science application to an original problem that is being studied. It does allow you to scale. It's very good for building national capacity of, or human resources of highly skilled individuals. It's interestingly enough, it's been found to lower the cost of research and allow the faster delivery of results, especially for things like national standards and competitiveness. Computational science has been one of the bedrocks of this. I guess maybe I'm preaching to the choir here, I guess. Okay. So training. I'll just speak briefly about approaches. I was actually thinking of bringing some activities. We've been working on activities in building capacities in this area for about, since 2005. So we do have examples of things that happened in Ghana as opposed to Ethiopia, to Cameroon, and to other places. But I just want to briefly talk about what I call approaches. So one approach that has been quite around for a while is sort of an intensive workshop or summer school or something similar like that. You could also call it boot camps. But usually the focus is on a hands-on transfer of knowledge. Okay, sometimes it may involve donating equipment. I think CHPC has already established itself in this area, both with donating equipment to neighboring countries from SADC, as well as running summer schools and workshops. I think this is quite common now. I believe almost every university in South Africa runs one or more summer schools in this area. These workshops tend to be very intense, and they focus on either an application or a particular topic or a particular discipline. What I would like to talk a bit more is now what's happening at, let's say, graduate or university level. So the first kind of approach we have seen is the one that a faculty decides to run a course on computational science, or HPC, for all the students in the faculty, or in certain cases, all the students in the university. The outcome is that every student in that faculty is able to use HPC facilities and is able to apply some knowledge to, it does involve a bit of coding, so they might be able to modify some code or understand better their research software applications. So this is one approach. The second approach, hello, are we out of battery? Oh, okay, wrong button. Okay, the second approach is one where you have a department, an academic department being created to look at computational science or a related topic. This is also intense, but it tends to happen over a period of 18 months, okay, whereas the broad university one is typically a semester course. And the capacity building activity tends to last weeks, so there are different durations. Sometimes the focus of the intensity is on developing mathematical models or developing algorithms, or even how to code mathematical algorithms into software. At the end of the day, this tends to produce graduates that can work in a variety of different fields. And typically the intakes for such departments come from different fields or different backgrounds as well. Two notable examples are a master's in high performance computing in Italy that happens at the ICTP. And there's also one that that's the ICTP worked with the Addis Ababa University to create one on the continent in, I think, as far back as 2008. And this was a master's in computational science specialization, HPC. Interestingly enough, they've transformed that now to a master's in computational data science. So they look at not only computational science as we traditionally saw it with HPC, but they are now also looking at data. There are examples of such programs also from many US institutions, and I believe institutions in developing countries as well. Okay, so some of the success stories, there are very many success stories I could point out, like we've had summer schools organized by CHPC and related or partner institutions here in South Africa. As well as ICTP programs, we do have workshops on HPC, science and technology, software development, research, data science, machine learning nowadays is becoming quite common. And so this is just a summary of what the three main approaches have been to training graduate students. I'm sure each person here may have participated in one or two of this kind of training. So if I still have time, I'll just briefly go into, still have time? Yes, okay, I'll just briefly go into some of the future initiatives. So one of the things I would like to present today is really the Consortium on Scientific Computing. This is part of the ICTP strategic plan, and it's about creating what we see as a win-win solution for computational science or HPC, machine learning and data science. Incidentally, the director of ICTP, the gentleman whose picture we see here, will be at the ICTP, will be in South Africa next week to sign an MOU related to this. I believe it will be with NITEX, yes, NITEX, the National Institute for, forgive me. Okay, so just some highlights of this. So it's part of the tradition of fostering scientific capacity development. So we would like to engage at a very high level. So this is why the director is more or less coming himself to engage with the national actors. Since it's focused on scientific computing, it covers much more than computational science or data science or machine learning. So things like the workflows could also be looked at as part of scientific computing. Things like the research software engineering, I think, will also be part of the scientific computing. We do look for strong partnerships in building what we call the 360-degree human capacity development. So which will include the training of end users, training of support staff, training of technical staff, especially in some of the target research areas. One other area where we are also looking to be very, very active is improving access to computational capacity and infrastructure. I want to also highlight the fact that CHPC over the last decade has also been providing access to researchers on the African continent to supercomputing class equipment, not only just for South Africans here. So that's a kudos, and I believe that this is something we would like to see more of. Of course, there's also the idea to create international research teams where scientists from South Africa and other countries can participate in international activities and engage with their colleagues worldwide. Of course, we do have our regular meetings happening. We do things in theoretical physics, in various aspects of pure maths, algebra, and things like that. We recently created a unit devoted to science, technology, and innovation, and are also partnering with respect to quantum computing. So we are looking at some of the things that are happening in future. Every year we do have activities. We do have a summer school and advanced workshops that look at various aspects of research data science. On the data science, we are looking at everything from urban planning all the way down to bioinformatics and things like that. We also, of course, still do regular activities about building clusters and even data centers and coding or scientific software development. We've also have programs that allow institutions, especially universities, to request for support. For example, if a university is organizing a meeting, they could request for some funding. It's probably just a few $1,000s to try and help them bring collaborators from neighboring countries. I believe that it sometimes allows them South-South collaboration, or even in certain occasions to bring collaborators from Europe or US down to participate in the events. One thing I would like to highlight is the fact that we're also starting a new PhD program in computational data science in the year 2023. I'm not sure, but it seems like this might be the first PhD program in computational data science happening on the continent here. So that's an achievement. There are several programs like the Physics Without Frontiers and Science Dissemination units that go on all the time. Thank you very much.
Thank you, Clement, for this kind introduction. I know you've worked on this for so many years. It's always good to see all these achievements. We have some time for questions from the audience.
So I was wondering if you could expand on that support. Do you offer financial support for students from South Africa to study or attend any of your courses?
Yes, there's always limited funding available for supporting participants from South Africa to ICTP activities. I believe that is also part of what is going to happen next week. There's going to be much more support available for South African students.
Okay, and just to use your contacts, I work in ocean climate modeling, and one of the most important things is getting the code to run really well on the machine, and that's algorithm design is part of that. And I'm wondering, who do you know locally that helps and supports that? Is there any specific training partners you know here?
Okay, I believe there was Mary Jane. I don't know if you know, I've forgotten her surname now.
Yeah, I know Mary Jane.
Okay, you know Mary Jane. So she's very well known here in this field. Incidentally, ICTP is also part of the authors, or we do have the software known as RegCM. I know some organizations use other software like WAF and so on and so forth, but RegCM, actually the code is maintained and developed by a team at the ICTP. So we do have collaborations like that, but we don't enforce any particular software model or software algorithm or implementation on people. So you are still free to work with whichever software you will like. Yes, yes. Yes, the Runge-Kutta equations, I guess. Yeah. So so you would like to have more training or somebody here locally who knows about the theory behind the applications. Interestingly enough, what I can say is that we haven't really invested in somebody, because most of the time people just want to use the software as a tool. Okay, and this is what we see happening across various fields. Another software which we run, or which we are also involved in the development, is known as Quantum Espresso. That's for material science. And in the same light there, we do have a flagship program on the African continent known as ASSESMA, where we try to teach people about electronic structure, how you can calculate electron density and things like that. And this happens at least once a year on the African continent. But I think the key thing is, at the end of the day, most people want to get their results and shorten the time to publishing. Okay.
That question there.
It's actually a follow-up to Nicolette. When you say you want to know more about the algorithms, there is an online master's program in Georgia Tech, and they've released one course as HPC algorithms, but it's master's level, but it's available online on YouTube. So it's if you're willing to dive into it, I can give you the link to that. I'm willing to try.
Oh, sorry, I thought you were talking about algorithms specific to weather and climate modeling. Yeah? No, oh, you meant just general HPC algorithms. Ah, yes. Yes, yes. Incidentally, the master's program I did mention, at least the one in ICTP, is heavily focused on that. So what they do is just develop algorithms and code the algorithms. So even new ways of doing things like integrals and stuff like that. Okay.
Any other question? I guess maybe I will end with my own question that actually kind of follow her question. I think in the past 10 years, with the advent of machine learning, AI, we are seeing more and more people doing more what I call using the data to train algorithm rather than doing the old tradition, modeling and simulation, where the computational science really took its root, where it became really the reason why it was even being pushed. And then what we're also witnessing at the same time, the new crop of graduate students, they are doing a lot of Python. They don't really learn much on how to optimize, are going to run all these, exercise all these systems, which means I was kind of listening to her say, sometimes you see, how do you want to tune even the algo to parallelize it? All those skills are really being lost, and we are seeing less and less people interested in those careers rather than the data science more, How do you address that? I mean, if you're going to promote the computer, the traditional, is then all these AI buzz becoming as a threat then for the old, do you have any comments on that?
I would like to probably start by pointing out that things like AI in reality involve some computation. Okay, most people don't know, but if you look at neural networks, in each particular node in a neural network, there's a transformation function that implements something mathematical. So at the end of the day, you have a series of micro computations happening that eventually transform your results into something. Interestingly enough, one of the ideas behind our talking about scientific computing is the fact that it allows us to address all of this, because they are not every field is able to make use of AI applications right now. I think for climate modeling, there's still a lot of challenge with respect to getting a functional AI model that can really predict the weather for tomorrow. It's not because we don't have enough data, but maybe we don't have enough periodicity in the data. My thinking is maybe when we have 500 years of data about the weather, we might be able to have a model that could give us a reasonable output. So the key thing is there's a place for all the various approaches. So if you want to do machine learning, if you want to do neural networks, it's all there. And they do have their roots in computation. So if you really want to understand machine learning and machine learning algorithms and neural network architectures, you do need to be able to understand and follow some of these computations. So in a sense, it's still relevant. It's not going to be pushed out of the way. Over the years, we've seen not just, I will say not just in computational science, but even in computer science, the regular computer science, we've arrived at a situation where now you ask a young graduate to write an application, and he goes to write you an application where he mounts several libraries. Okay, I remember when I was studying as a young graduate, we needed to do things like optimize algorithms, maybe bubble sort, and look at the various sorting algorithms and how to implement them on the computer platform. But now there are libraries that do that for everyone. I think in a sense, this is what standardization is helping to achieve. So that way the young programmer does not create a problem, okay, for the software, because he's writing with code that has been profiled and established. We will need to encourage people, we'll need to get them interested once again in developing new algorithms. And I think quantum computing in this respect is quite exciting because it affords us this opportunity. A lot of the algorithms we have nowadays in computational science need to be ported to quantum computers. We need to have them work efficiently on platform quantum computers. So that's my message to the young people. If you really want to get into algorithms, look into doing something with quantum computing. That's the future.
On that note, let's give a round of applause to Dr. Clement Onime. Thank you. And this is a token of appreciation. Thank you again.